Okay, so let's say that we have a capacitor of capacitance C naught that is charged such that at t equals 0, there is a voltage across the capacitor V naught. And then we connect it to not an inductor, but to a resistor of resistance R naught. And at t equals R naught C naught, which is the time, let's find the energy in the capacitor. So the energy in the capacitor EC. That's what we're looking for. So we know that energy in the capacitor goes like charge squared over 2C. And so we need to know what Q is at different times, because we know what 2C is. It's 2C naught, because we have the capacitance. So the question is, what's Q? Because we need to square Q. Well, we solved for the charge on the RC, in the RC circuit, for the charge on the capacitor of the RC circuit, and it behaves like this, e to the minus t over RC, which, well, we don't have Q naught here, and we do know the values of R and C, so we need to first find this in terms of known quantities. But from the definition of capacitance, in this case, given the values that we have, it's the charge over the voltage. The voltage is known, so the charge, sorry, this would be the initial, what we call the Q naught, which we don't have. So we solve that in terms of the known capacitance and voltage. So that looks like that. And so we can write that Q is C naught V naught e to the minus t over R naught C naught. And at t equals R naught C naught, Q is C naught V naught e to the minus 1. But we care about Q squared to construct the energy in the capacitor. So we need C naught V naught e to the minus 1 squared over 2C naught, which is C naught V naught squared e to the minus 2 over 2. And that's the energy in the capacitor. Notice that in terms of the energy at t equals R naught C naught, let's calculate the ratio of the energy at that time compared to the initial energy at t equals 0, when the capacitor had the voltage V naught and the charge C naught V naught on it. This is, so we found this value, which is this. I want to write this again, but EC, so let's write EC at t equals 0, that is just Q squared over 2C, so that is C naught V naught squared over 2. And so this ratio is this divided by this, which is e to the minus 2. So we have like 1/9 of the energy that we had initially.